Hello everyone. So I gotta be honest with you guys. I'm starting to wonder how weather forecasters do this because we're like 5, 6 days out from this storm now, and the models just go all over the place from run to run. There's no consistency whatsoever. I'm gonna be potentially be a weather forecaster one day. I'm still in college, and I'm looking at these models just trying to get something, and it's so incredibly difficult to do that because there's absolutely no consistency beyond 4 days. Sometimes even shorter than that before the storm. There's no consistency. So, I'm gonna do my best here. The GFS has just been literally all over the place. It's fluctuating between going north and going south and coming back north, and then it goes back south again, and it's creating two storms instead of one storm now. So it's just like, oh my god, seriously, make up your mind. Anyway, so that's the frustration that I and other forecasters are dealing with right now. So I'm gonna just try my best here to go over some of the factors that are going to play into this storm. I'm going to do this by comparing excuse me. Excuse me, still getting over some bronchitis here. I'm going to do this by comparing last night's GFS to tonight's GFS. Okay, so looking at last night's GFS, it appears that there's going to be several pieces of energy. Alright, here's one. This comes down from the Gulf of Alaska like this. And then here's energy in the southern stream coming in from the Pacific. And, at some point, these two pieces of energy are going to come together, but there's a couple of things here. In last night's run, you see this northern piece of energy is closed off, so that's the dominant piece. This is, by the way, next Monday afternoon. So this is the dominant piece in last night's run. But in tonight's run, notice that the northern piece is way back here, and your southern piece is all the way out to the south and east, and it is closed off, so guess what? Now the southern piece is dominant. So my thinking is that where is this energy going to track? That's the key here. Where is this energy going to track? My thinking is that if this energy stays separated, then I think your southern piece is going to be further south, because it'll be on its own longer. However, if the northern and southern piece come together earlier, then the northern piece, especially if it's dominant in the flow, can track this further north rather than further south. And if you go through this here, that's kind of what you see. You see how far north this is? Because the northern and southern piece come together here. Notice this connection is going to start to develop. And so it stays to the north as such. And then if you go towards the new run, you see it is all the way down across the mid-Atlantic in here, as your northern piece is way back here. Then the other thing to notice is you have a little more energy coming in here from the Pacific that could also phase with this. I think that's why the GFS creates two storms, because it has this extra energy coming in on the back end, and maybe it's going to phase the northern piece with this piece of energy rather than this piece of energy. In fact, I didn't observe that. Let's see if that's what happens. Yeah, that is what happens. So now you're going to have a storm form in here later Wednesday, and then that'll track somewhere. Okay, so anyway, looking at the old run, you see there is no additional energy that comes in, or it looks like it's all back in here. So you only get one storm. But in the new run, there's additional energy coming in that's stronger, so you get 2 storms. Alright, and then the other thing to notice, if we go, let's go to Tuesday evening for a second. Alright, first off, in the new run, look where this is. Your storm is all the way over here. Way over here, and your northern piece is all the way back here. So that's a big difference, because in the old run, the northern piece is phasing here, and your storm is much slower. This is the old run, and this is the new run. So in the old run, it's much slower, and it's further north, because that northern piece has phased. Excuse me. Now, in the new run, though, there is something a little bit different. Notice how, I'm still trying to put my finger on this as I'm looking at it. Do you guys see how the flow is a little more flat? This is the old run. It's a little more zonal. And the reason it's a little more zonal is because you have this ridge building in the west. You see that? You have this ridge building in the western states. And it's a lot sharper in the new run here. You see that? Look at how sharp it is in the new run compared to the old run. Old run, new run. Old run, new run. So, your flow is a lot more zonal in your old run as compared to your new run of the GFS. That's another thing that the models have been struggling with. How potent is this ridge in the west? Does it build up strong enough so that your flow is more amplified? And if the flow is more amplified, then my thinking is that the southern piece will actually be able to dig further south and then round the bend and come up. Like such. If your flow is flat, if it's zonal, like this, then it doesn't really dig, it just travels to the east. And whoever's on the northern side gets accumulating snow. But if your flow is more meridional, then your storm can dig further south based on the flow and then come back up. But even in that scenario, I'm trying to decide what plays more of a role. Is it the fact that in the new run, this northern piece just stays back and lets the southern piece do its thing, and it comes further south and then rounds the bend and comes up? And then in the old run, the northern piece says, no, I'm catching you, and it stays further north. So I'm just trying to figure out whether it's the flow, or if it's the northern piece, whether or not this phasing happens that keeps this storm north or south. So it's one of those two things or both combined. And I also think that the position of this ridge is going to play a role. The other thing that the models have been struggling with is the placement of this ridge. Some of them have it further west. And if this ridge is further west, then this troughing is further west as well. And then your storm will definitely dig and come up. So you just have to look at the large scale flow and ask yourself, where is this storm going to go? And you know, the models can't even get the large scale flow figured out, let alone this phasing of the energy. And so, I don't even know where to draw a threat area right now. I think the only thing I can say on this is that the one thing that the models are good with is that they do show threats for storms. They no idea where the storm's going to go, even 4 or 5 days out. They have no idea. There's just no idea at all. But what they do a good job of doing is showing when there's going to be a threat for a storm. And the models have shown that there is going to be a threat for a storm. This would be next Tuesday into Wednesday. You know, lately the models have been trending further north so that this area would get clobbered. But as I said before, it could also trend further south so that the Mid-Atlantic gets clobbered. So I'm just going to draw a really big threat because I have no idea. This is my threat area, basically the entire Northeast. Everybody, just watch this, everybody. No matter where you are, just watch this for the next couple days and we'll see what happens. You know, as we get closer, I'm hoping the models will get a little more consistent here. Set up the large scale flow a little better. Figure out what this northern piece is going to do, what this southern piece is going to do. Is there going to be an additional southern piece behind the first southern piece so that there's 2 storms? So, that's where I'm at right now. I know it wasn't the most informative video. I apologize. I'm trying my best here as I try to get caught up on schoolwork as well. And, you know, these models are giving me a headache as I try to figure out some semblance of a solution here. The other thing, though, about this storm, one thing that's been really consistent, if you look at the surface map, oh, it disappeared. You see you have a high up here. It's a little further south in the new runs, which I like. But you have this high up north. So this is going to be supplying cold air. So there is going to be an injection of Arctic air with this storm. So somebody is getting snow. Somebody somewhere is getting snow with this. So again, let's keep an eye on it. The Arctic air is there. The storm's there. It's just, where's the storm going to go? How is this energy going to interact? What's the large-scale flow going to be like? Alright, thank you for watching. I'll try to post another video update either tomorrow or Friday.